In this problem, we've been given f of x, and we're being asked to build the third degree Taylor polynomial. And so I don't remember if there's anything, like this isn't sine cosine e to the x, 1 over x minus 1. I'm going to have to build this one out. So I'm going to need the following. So here's our general formula for building a Taylor series. And since I have x minus 1 that I'm building around, and I need a third degree, then I'm going to need several derivatives. So the first one that I need is just ln of 2 minus 1. That's my f of 1. Well, 2 minus 1 is 1, and ln of 1 is 0. The next term, I'm going to need the derivative of f. So if f of x equals ln of 2 minus x squared, then I'm going to need f prime. Well, it's going to be 1 over 2 minus x squared times the derivative of the inner, which will be negative 2x. And I'm going to need that when x equals 1. So I'll plug a 1 in here and a 1 in here, and I will have negative 2. 1 squared is 1, and 2 minus 1 is 1. So this portion right here is going to be negative 2. So I can erase that. And just replace this with negative 2, x minus 1 to the 1 over 1 factorial. Well, now I'm going to take another derivative, and unfortunately now we're looking at the quotient rule. So we're going to have our second derivative will be the derivative of the numerator, which is going to be negative 2 times 2 minus x squared, minus the derivative of the denominator will be minus 2x times the numerator was another negative 2x all over 2 minus x squared all squared. That's the second derivative. When I plug in a 1 for every x, I'm going to get negative 2 minus 4 is negative 6 all over 1. So my next term will be negative 6 times x minus 1 to the second power all over 2 factorial. Well, that second derivative could be simplified and simplifies into what you see in red here. The reason I needed to simplify that is because I need to take the third derivative if I'm going to get the third degree Taylor polynomial. So one more derivative, we'll have another quotient rule. To save your time, I'm going to just do it and you can look at it when I'm done. So after doing the quotient rule, we get what's in red here. It's kind of a mess, but all I have to do is plug in 1 for every x. So I'll pause the recording and do that. Plugging in a 1 everywhere, I get negative 4 plus 8, or 4, as my third derivative. So that's going to go at the very next term. I'll erase some things. Here we've got a positive 4 x minus 1 to the third power all over 3 factorial. After simplifying, we have what you see here in blue. This is the third degree polynomial. It has everything stopping at 3, versus the third degree term would just be this term. So that's a little bit about vocabulary. If you want the third degree Taylor polynomial, you want everything, all of the terms in the polynomial, because a polynomial has many terms, up until the largest term they ask for.